Hey y'all, we are back for 0.3 part 1, where we are solving equations. And I highly encourage you in this section to actually pause the video pretty much now and solve through as much of this as you can, or maybe just try them all, even if you have no clue if you're doing it right. Try them and then go back and double check with my answers. Because most of this should be review. Some of them are getting more difficult than you've seen before. But it's all stuff that I bet you can figure out. And if you can't, then obviously tune in, listen to me go on about all things math and nerdy. So, we just need to make sure as we're solving equations that we still follow the order of operations. It is so important that when we are combining terms, we follow that order of operations forward. But when we are trying to isolate the variable, which is step 3 here, when we're trying to isolate that variable, we just need to make sure that we are kind of like undoing those order of operations backwards. We're going to isolate the variable by getting rid of addition and subtraction first. And then we're going to get rid of multiplication or division. And then finally, exponents, parentheses, etc. Okay, so let's look at how that works. Solve each equation below for, whatever the given variable is. Okay, step 1 is to distribute unless it's easy to divide both sides. So one option in this problem would be to start by dividing both sides by 6. And that saves me from having to distribute and then resolve. The issue is if I divide both sides by 6, 2/6 is going to either stay a fraction or a repeating decimal, right? That's going to simplify to 1/3. And I really don't want to deal with fractions this early in the problem. It's not the worst thing because we do have a calculator. Our calculator will deal with those fractions for us. But I just like to avoid them if I can. So I would, in this problem, choose to distribute first. 6n plus 30 equals 2. And I mentioned at the beginning of this video, we do need to do that order of operations. But when I am isolating the variable, I'm actually going to isolate it backwards. I need to, because again, my goal is to get this n all by itself. I need to get rid of any addition and subtraction first. So, and the way I like to think of it, I like to think of multiplication and division as being stronger than addition, right? Because this 6 is much more closely affecting the n than this plus 30 is. So I need to get rid of the stuff that's not as close, or the weaker stuff first, before I get rid of the stuff that's closer with that n. Okay, so I am going to get rid of this 30. I need to leave the equation equivalent or balanced. So if I take away 30 from this side, I need to make sure I take away 30 from the right side there. And we are left with 6n. Remember with those inverse operations, plus 30 and minus 30, the reason it goes away is because this would just turn into a plus 0. There's nothing left that I'm adding. So I don't really have to add the plus 0. So let's go ahead and get rid of that. Equals negative 28. Okay, now I can get rid of that 6. I'm going to divide by 6 because 6 divided by 6 is 1. And we talked about in the last lesson, we don't really have to write 1n. It's just the same as just n isolated by itself. But if I divide one side by 6, I need to leave the equation balanced by dividing the other side by 6. And we can use our calculator to simplify that fraction there. We end up with n equals negative 14/3, I believe. And there is my solution. I have solved the equation. N should be negative 14/3. And you can check that really easily. You can check it by plugging it back into your calculator. 6 times negative 14/3 plus 5. And when you press enter, we should hopefully see that the answer is 2. So I know that I solved that correctly. Okay, 3 times 5. I'm just recopying the problem here for this one. Alrighty, so I probably want to get rid of this fraction first, right? So I can, especially since this is almost like grouped, right? We talked about the fact that a numerator is kind of like a grouping symbol. So I can get rid of this -4 that's on the outside of that group by multiplying both sides by -4. And we can think of that as -4 over 1, right? Because those would cancel out. But if I multiply the left side, I need to multiply the right side in order to leave the equation balanced. Okay, so I am left with 3 times 5 minus 3x equals positive 60. Okay, and on the last problem, I distributed the number on the outside. But if I kind of look ahead, I can see that I can easily divide both sides by 3, and I don't end up with a fraction on the right side like I did with the previous problem. So that might actually save you some time. Instead of having to distribute, let's get rid of that 3 first. I'm going to divide both sides by 3. It does not affect what's inside the parentheses. Those are kind of like, I like to think of it as being protected by the grouping symbols. It's just the 3 is going to cancel each other out. I'm left with 5 minus 3x equals 20. Okay, I need to get rid of this 5, and it is so tempting to add 5 to both sides because you see this subtraction, right? But what we need to make sure is that even though it's subtraction, remember it also is kind of like adding a negative, and that negative belongs to the 3. In order to get rid of the 5 on this left side, we need to subtract 5. And just looking, I'm going to undo this. That makes sense because I have 5 minus 5. That does end up going away. That ends up being 0. So let's get that back. There we go. So we do need to subtract 5. I erased a little bit too much there. Okay. This negative, or it's a minus, but it is also like a negative that belongs to the 3. So minus 3x equals 15. I'm going to go ahead and move my work on up here since I am out of room. And when I do this, I like to recopy the problem just so I don't make any silly mistakes. Forget a negative or something. Divide by -3. Divide by -3. X equals -5. And again, you can check that by plugging it back in the calculator pretty quickly. Alrighty, next problem. Again, these are so important that you just check to make sure you know what order to do by yourself. You can watch me do these all day, but it is so important that you practice making these decisions for yourself, and sometimes they'll be the wrong decisions, but that is how we learn. You do not learn by doing everything correctly the first time. If you're doing it all correctly the first time, then I really haven't taught you anything. You knew how to do it to begin with. And we don't want the time that you're making mistakes to be when you're taking a quiz or a test. We want to make mistakes on practice. Please pause the video, make mistakes on the notes, make mistakes on your homework, and learn from them so you don't make mistakes on the assessments that count a lot more towards your grade. Also, I'm pretty notorious for making mistakes if I'm talking while I'm doing work, so if I've made any mistakes, please feel free to correct me. We can double check that in class and we can revisit what I did wrong. And we can learn from them. Okay, y equals 8 times 7 is 56, so -8. And you know what I didn't do? I didn't rewrite the problem when I said that I'd do that when I ran out of room like this. But notice I had already written the step down. I had already written divide by 7. So I'm really just simplifying the problem at that point. Okay. So this one's interesting. This one I have the variable on both sides. But I can think of this just like in the last lesson. I can think of it as combining like terms. I definitely need to combine these two a's together. I'm going to erase that so it doesn't look like I'm dividing. I need to combine those a's. And it doesn't matter which side we pick. I'm going to move the a's to the left side. And this is 21 minus 6a. So to move that, I'm going to add 6a to both sides. Okay. And then I can combine those constants. And can she simplify this in her head? I think I can divide them both by 4, so 7/4. There we go, and we can double check to make sure it's right. In this problem, we cannot type that equal sign into our calculator. So what you need to make sure that you do is that we plug in the left side by itself. So 10 times 7/4 minus 7, which if you type that in the calculator, oh Lord, 70/4 is going to be 35 halves, and 35 halves minus 14 halves is and you don't need to do this in your head. I just don't have my calculator with me, which is always dangerous. Okay, so 35 minus 14 is going to be 21 halves. Again, please correct me if I'm wrong. Okay, 21 halves for the left side. We just need to make sure that that is still true for the right side of the equation. So totally separately, I need to check what is 21 minus 6 times, I think the answer is 7/4. Okay, so then we can 21 minus 42 fourths is going to be 21/4, which is going to be 21 halves. It looks like everything's correct. Look at us go. Alrighty, so that's just how you would have to check your answer if you have variables on both sides. Alrighty. Ooh, fun trick for E. So we can see a lot going on here. And what I want to do, I don't really love working with fractions. So what I can choose to do is look at the fractions that I have, and if I multiply every single term by the least common denominator, and it looks like the least common denominator here is going to be 6. So if I multiply both of the equations by 6, I'm going to multiply this guy by 6, and I'm going to multiply this guy by 6, then it's going to get rid of those fractions, and maybe my answer ends up being a fraction, but I don't have to deal with it for the majority of me solving. The caveat to that is, if you're using your calculator, it doesn't really matter if you have fractions, because it's not any harder to type in a fraction than it is to type in a whole number. But especially since I'm doing a lot of this in my head, I need to get rid of the fractions. Okay, so make sure that we distribute this 6 then, and we end up with 5w plus 126 equals, and remember we talked about earlier, these parentheses almost act like a protection for what's inside. I'm only going to multiply this 6 by what's outside. That's going to kind of absorb it before the parentheses do. And I can distribute it later, I just don't need to right now. Okay, so negative 2 times 2w minus 9. Okay, this is a situation where I have a choice. I could distribute this negative 2 now, or I can check the other side and see, are both of these easily divisible by 2? And this one is, but I would end up with another fraction, and I don't really want to deal with that right now. So I'm not going to divide by negative 2. I'm going to distribute it. And that's a really important thing for you to remember, is just because I do something one way does not always mean that it's the best way. It's obviously the way that I prefer or that I think is going to be easiest for you, but you can make decisions for yourself, and that's why it's so important that you pause the video and try these for yourself, because if you find a different way to do it, chances are it's okay that you do that for every problem. You just need to be careful, make sure you're following the same general math rules or guidelines that I am, but there's always 7 different ways to get to the right answer. Oh no, can she do this in her head? Let's see, 10 less than 126 is 116, minus another 8 is going to be 108, so that's negative 108, I believe. I am out of room, so I'm going to copy that down again. Make sure that okay, positive 9x equals negative 108. Oops. Divide both sides by 9. How did I change from a W to an X? That's kind of funny. Let's go back and fix that. Must have been because I was talking at the same time that I was writing. Okay, those are changed back to W's. That makes a little more sense now. And we end up with W equals negative 12. And we can double check that, again, by just typing that answer in with parentheses individually to each side of the equation, right? We need to check the left side first and then check the right side. I will let you do that by yourself. Alrighty, we have, again, grouping in the numerator here. And so I want to go ahead and get rid of this divide by 2 first. So if I'm dividing by 2 first, I'm going to multiply both sides by 2. Make sure that we multiply this whole side by 2. I need to distribute that. Instead of distributing this 2 to everything in the numerator, it's just going to immediately cancel out with that denominator. That's why we chose 2 to multiply by. And we end up with 10x plus 17 minus x minus 9. Okay, I'm going to go ahead and distribute this 2. Let's zoom out so we can see the whole problem at once, Miss Saxton. Okay, and a couple different choices that we have here, but what I think is going to be best is let's go ahead and combine like terms on the left side of this equation first. And now I'm going to continue combining like terms, but since it's across an equal sign, I need to leave that equation balanced. And in a shocking turn of events, I am out of room. Let's double check and make sure I was using the right variable. Yep, those were x's. So we have x equals negative 8, and again, check it by plugging it back in. Okay, let's see what's so special about these special cases. I'm going to start by distributing. Let's combine like terms on the right side here. Okay, and I'm going to continue combining like terms. And this is interesting. 3c minus 3c is 0, so that goes away. 3c minus 3c. That I meant for that one to be 0, so that goes away. And I end up with the statement 1 equals 5, which 1, in fact, does not equal 5. So if you end up with a variable disappearing entirely, and you're left with an untrue statement, it might be 1 equals 5, it might be negative 4 equals 0, but regardless, you might end up with 0 equals 4. None of those are correct. None of those are true statements. So if you ever end up with an untrue statement, there's going to be no solution to this problem. Okay, let's look at a different special case. Oh, interesting, actually. So we could have distributed. I was about to distribute this negative 8. But then I looked and I was like, can I divide both of these easily by negative 8? And actually I can. So I think that's actually the choice that I'm going to make. Do I have to do that? No. You will get the same regardless. Maybe you distribute and see how your answer ends up similar, but maybe slightly different than mine. Well, your answer will be the same, but the way that we get there might look slightly different. Okay, so I'm going to divide by negative 8, divide by negative 8. And when we divide this by negative 8, just like when we multiply, we need to make sure we divide each individual term by negative 8. Okay, so we end up with negative 5 plus, right, because a negative divided by negative is going to be a positive x equals, that canceled, x minus 5. And maybe you already see where this is going, but normally my next step would be combine like terms. So I'm going to go ahead and combine those x's, subtract x from both sides. And we end up almost in the same spot that we did in A over here. We end up with my variable disappearing entirely. The difference, though, is I ended up with negative 5 equals negative 5. Maybe you ended up with, actually I think you would have ended up with positive 40 equals positive 40. Or maybe you even end up with 0 equals 0. Regardless of which way you solved this, you end up with a true statement. So this means that x can be any value. You can pick anything you want to plug in to the original equation, both sides individually. But no matter what you plug in, it's going to end up being true. So what we can say is x is all, or could be, I'm just kind of being lazy and saying is, but x could be all or any, I'm going to put any, makes a little more sense, is any real number. And again, that means x, I don't know why I wrote that in red. There we go. Okay. What that means is x could be 4, x could be negative 3, x could be pi. Pi is a real number, it's irrational, but I could plug pi in to both sides of this equation and it would make it true. And that's an important takeaway, and that's why those are two special cases. So let's go ahead and highlight this guy too, just for consistency. X is any real number are two different options for special cases. Okay, on to the back. Solving proportions. So I'm sure you have heard before, right? If we're solving proportions, we cross multiply, or the butterfly method or something. But I want to talk about why that works. It does still work. We can still use it. We can do the butterfly method. We can do cross multiplication. But the reason that that works, I'm going to copy it down so we can see why. Is what I'm doing is I'm just solving an equation like normal. I am going to get rid of this 3 in the denominator by multiplying both sides by 3. That's something we've done in a couple examples already. Okay, and then I'm going to get rid of this x plus 4 on this side of the denominator by multiplying both sides by x plus 4. We need to be careful with parentheses, right? We need to make sure we put that in parentheses. And hopefully what we notice, the 3's cancel out on this side. The x plus 4 and the x plus 4, I'm going to do kind of weird cross, cancel out on this side. What we end up with is x plus 4 times 5 on the left and 2 times 3 on the right, which is just basic cross multiplication. 2 times 3, I ended up here. 5 times x plus 4 on the left. And so, yeah, I mean, it still works. The reason that it's taught is because it is mathematically sound, but it's important to me that you understand why it actually works so we don't make silly mistakes with that cross multiplication, because it only works if there's an equal sign in the middle. Okay, but we got it all set up. Now we can solve. I'm going to go ahead and distribute this 5. 5x plus 20 equals 6. Subtract 20 from both sides. Divide both sides by 5. X is, and that does not simplify, negative 14/5. Beautiful. Okay, so again, we can think of this as cross multiplication, but really all I'm doing is multiplying both sides by the denominators. So we end up with 10 times 2x minus 8 equals 8 times 5x minus 9. I am going to go ahead and distribute both sides. Yes, there are other viable options. This is just what I'm choosing to do. It is just personal preference that I always like the variable on the left-hand side. Plenty of students like to move the variable in whichever direction is going to make the coefficient positive, so maybe subtracting 20x from both sides. That is absolutely fine. My way is not better. It is just because I prefer the variable on the left side of the equation. So you do you. We end up with the same answer. Or we should end up with the same answer, as long as all of my mental math is correct. Which I'm good, but I am certainly not perfect. Especially when I am yapping while I solve. Divide both by 4, we end up with negative 2/5, I believe. And notice how I moved that negative. In a fraction, right? So I'm just gonna, let's use negative 2/5 as an example. Well, I guess my fraction did not start like that. My fraction started like this. Which, if I left the negative where it is, that would be divided by 4. Okay, and we have a bunch of different ways that we can represent this. This means the same thing as I like the negative in the numerator. I think it looks better. Plenty of people like to put the negative in front. I really do not like that, because if you're not careful, it kind of just might look like one big fraction bar, right? And that's kind of sketchy. Oh, let's get rid of that. There we go. So I don't love that one, but it is technically correct. What is absolutely not correct, we cannot write a negative in the top and a negative in the bottom, right? Because a negative divided by a negative would simplify to positive 2/5. So I can't create an extra negative, but I can move that negative wherever I want to. So just kind of a nice little side note. Okay, example 4, we're just practicing solving literal equations, which actually ends up being less work than the other problems. They look scarier because there's so many variables, but there's not very much simplifying that we do. Okay, so solving for pi means I want to get the pi all by itself, which means I need to get rid of these other things with pi. And they're both being multiplied, so I can just divide by 2r to get rid of the 2r on that right side. So I need to divide the left side to leave the equation balanced. We end up with c divided by 2r equals pi. That is exactly what the directions told me to do. Solve it for pi all by itself is really what those directions mean. Solve for pi all by itself. And there we go. We did it. One step. They're not all going to be one step. Okay, solve for p. So I'm trying to get the p all by itself. And this is when you have options. I would really like to do this in 2 steps, though. My first step is going to be, let's get rid of that fraction. So if I just multiply both sides of the equation by 2, so multiply this side by 2, multiply this whole side by 2, that's going to get rid of that fraction for me. I end up with 2a equals ap, and now I can work on getting that p all by itself. Divide by a, and there is nothing I can do to simplify. Notice there are different types of a. Big A and little a are not going to cancel. They are different variables. And I have solved for p all by itself. Oops. Hello? There we go. Okay, solve for b. So again, b is like kind of in grouping symbols up in the numerator here. Those are grouped, which means I need to get rid of that c first. That's something we've been doing on the front side of these notes. So I'm going to start by multiplying both sides of the equation by c. Trying to get the b all by itself, so I'm going to go ahead and subtract this a. And there we go. Goodness, it's just not like in my Zoom. Okay, option D. I highly encourage you, if you've been following along, try pausing it, solving these, and then just checking your answers with me. And you just have to listen to me yapping if you are stuck and not sure what you did wrong on a problem. It doesn't really matter where you put the 3y. We can put the 3y in front, we can put the 3y at the end. Make sure we distribute that divide by 3. We have to divide both of them by 3. And I just want to make a note that you could also write the answer y plus a, right? Because addition's commutative, so it does not matter what order those go in. I wouldn't have changed anything. I would have left it the blue way, but if you have the other one as an answer, that's great. Okay, we're solving for v. Instead of distributing, I'm going to go ahead and multiply both sides by 2. We're trying to get the v all by itself, so I'm going to go ahead and move the w over. And there we go. Now v is all by itself, so we're done there. Okay. It's not wrong to distribute first, but you're going to end up making a little more work for yourself, so I'm going to go ahead and divide by 180 first. Okay, notice I do not put this plus 2 in the numerator. I'm adding 2 to this entire right side of the equation. If we wanted to put it in the numerator, or maybe if you distributed at the beginning of the problem, you would have to, basically you end up with a common denominator. You end up with s plus 360 over 180, right? Because 360 over 180 would simplify to 2. So both of those are perfectly correct. My way's not any better. It was just faster for me to solve it that way. Okay, so there's that section. We got 2 SAT, ACT problems. And then we are done with this lesson. Okay, so here without reading, not that there's much to read, we have this equation. And then it wants what is z in terms of x and y, meaning z is going to be on one side of the equation, x and y are going to be on the other. Okay, so we have maybe multiply both sides by 5 first to get rid of that fraction. Divide both sides by y cubed. And glancing through my answer options, that sure looks like C. And we could kind of narrowed it down from the beginning just with the, I know that the 5 and x need to be multiplied, so it's definitely not A, it's definitely not B, and it's definitely not D. I really only had 2 options where the 5 and the x were together, and then it's just a matter of, do I end up multiplying by y cubed or dividing by y cubed? Okay, we're given an equation. What does 5 minus x squared absolute value equal? And that just means I need to solve for x first, so well, I guess I'll just use blue. I don't really like to switch colors. Okay, I got x equals -3. So you absolutely have the option of just typing this in your calculator. You need to be so careful about parentheses though. It absolutely has to be 5 minus parentheses -3 squared. You're going to get a totally different answer if you don't put those parentheses there. Once again, I do not have my calculator, so absolute value of -4 is 4. And there we go. You guys can go ahead and do your 0.3a homework, and I will see you for the next lesson.